Now, I hope the Hessian matrix നിങ്ങൾക്ക് മനസ്സിലായി എന്ന് ഞാൻ മനസ്സിലാക്കുന്നു. ഇനി നോക്കൂ, നമുക്ക് അടുത്തൊരു കൺസെപ്റ്റ്, ദി ഹെസ്സിയൻ ഹയർ ഓർഡർ ഹെസ്സിയൻ മെട്രിക്സ് ആൻഡ് ഹയർ ഓർഡർ ഹെസ്സിയൻ ഡിറ്റർമിനന്റ്. ഹയർ ഓർഡർ നമ്മൾ നേരത്തെ പറഞ്ഞ എക്സാമ്പിൾ, z is equal to function of x and y. Z is the dependent variable, x and y are the independent variable. We have only two independent variable. What happen if we have more than two independent variable? For example, if we have a function y is equal to function of x1, x2, x3, we have a three independent variable. And these three independent, in this case, if we have a more than two independent variable, then we are going to apply higher order determinant. See, in this case also, the first order condition endanu? With respect to, we are going to take the partial derivative with respect to x1, then equating with the 0. Partial derivative with respect to x2, we are equating with the 0. Partial derivative x3, which is equating with the 0, because we have a three variable. For example, we have one more variable x4, then the partial derivative with respect to 4, which should equate with the 0. So this is the first order condition. Then see, we are going to create a Hessian matrix which composed of the second order partial derivatives in this particular format: y11, y12, 13, 21, 22, 23, 31, 32, 33. See, in this case, the direct partial derivatives are on the principal diagonal. y11, y22, y33, all these are the direct partial derivatives which are taken on the main principal diagonal elements. Okay, so now accordingly we can interpret. See, the condition for relatively minimum or maximum, which is depending upon the sign of first, second and third principal minors. എന്താണ് നമ്മൾ വെദർ ആക്ച്വലി മാക്സിമം ആണോ മിനിമം ആണോ നമ്മൾ ഡിറ്റർമൈൻ ചെയ്യുന്നത് ഫസ്റ്റ് ഓർഡർ, ഫസ്റ്റ്, സെക്കൻഡ്, തേർഡ് പ്രിൻസിപ്പൽ മൈനർ നോക്കിക്കൊണ്ടാണ്. വാട്ട് ഈസ് ദി ഫസ്റ്റ് പ്രിൻസിപ്പൽ മൈനർ? ദാറ്റ് ഈസ് y1. What is the second principal minor? That is this 2 into 2 matrix, this 2 into 2 matrix. What is third principal minor? See, all this H will become H3. Now see, H1, that is first principal minor, which is equal to y11. Okay, now H2, that is 2 into 2 matrix. First 4 element will be considered, that is 2 into 2 order, that is y11, 12, 21, 22. And we want to find out the determinant value. Then H3 is nothing but which is equal to H. So this 3 into 3 matrix will be considered. Now looking at the sign of H1, H2, H3, we can determine whether the function is relatively maximum or relatively minimum. See how we are going to determine. See, the second order condition for minimum, H1 is greater than 0, H2 is greater than 0 and H3 is also greater than 0. That means these three principal minors are greater than 0. The first principal minor, that is y11, which is greater than 0. Then we have a 2 into 2 matrix, that is H2 Hessian, higher order Hessian, which is greater than 0, and H3, that is equal to H, that is greater than 0. If these three are greater than 0, then this is the condition for a minimization of a function. Okay, now for the maximization, the second order condition, that is H1, that is first principal minor, y11 is less than 0. Then H2, that is y11, 12, 21, 22, that is 2 into 2 matrix is greater than 0. Then H3, that is H, which is less than 0. See, we have an alternative signs here. Here it is less than 0, greater than 0 and less than 0. H1, it is not greater than, it is H1 is less than, H2 is greater than and H3 is less than 0. So this is the maximization. If everything is greater than 0, then this is the condition for minimum. But if we have alternative signs are there, which is starting from H1 which is less than 0, then it is generally considered as the condition for the maximization. Now let us consider one example so that it will be more clear. We want to optimize a particular function y, which is the function of three independent variable, x1, x2 and x3. So we want to take the partial derivative, because of course we have more than 2 independent variable, that is x1, x2 and x3. So here we are going to apply higher order partial derivatives. So first we are going to take the partial derivative with respect to x1, x2, x3 separately. So with respect to x1, I am denoting in terms of y1. See, with respect to x1, if you go for taking the partial derivative with respect to x1, then it will be 10 minus 10 x1, 10 plus 10. Then here we have x1 by keeping x3 as constant. So the derivative of x1 is equal to 1 into x3, which is equal to x3. Then it is x2, x3. There is no x1 term. So the partial derivative with respect to x1, which is equal to minus 10 x1 plus 10 plus x3, which is I am equating with 0. Now y2, that means I am going to partially differentiate the y with respect to x2. See, where is x2 term? There is no x2 term here. We have x2 term here. Minus, actually we have minus 2x2 square, minus 2x2 square. So we are differentiating with respect to x2. So it will become minus 4x2. Then plus 4x2, the derivative of 4x2, which is equal to 4. Then we have here 2x2 x3. Keeping x3 term is constant, we are going to take the partial derivative with respect to x2. The derivative of x2 is equal to 1. So 1 into 2 into x3, which is equal to 2x3. I am equating with 0. Similarly, we have one more partial derivative here because we have a 3 independent variable, that is y3. So I am going to take the partial derivative of y with respect to x3. See, where is the x3 term? Here we have x3 term. By keeping x1 term is constant, the derivative of x3 is equal to 1. So 1 into x1, which is equal to x1. Similarly, here we have x3. By keeping x2 is constant, the derivative of x3 is equal to 1. So 1 into 2x2, which is equal to 2x2. Then we have finally minus 4x3 square. The derivative of minus 4x3 square, which is equal to 2 into 4, which is 8x3. Minus 8x3, that is the partial derivative with respect to x3. And then I am equating with 0. See here, as against the earlier case, now we have 3 partial derivatives. One is with respect to x1, another one is x2, and the third one is with respect to x3. So we have y1, y2 and y3. Now we are going to frame a higher order matrix. Higher order matrix. What is the higher order matrix? Higher order Hessian matrix composed of all the second order partial derivatives, where all the direct partial derivatives are taken along the principal diagonal and all the cross partial derivatives are taken along the off principal diagonal. So here the principal diagonals are y11, y22, y33. All these are the direct partial derivatives. So what is y11? We are again going to differentiate y1 with respect to x1. So if you are going to differentiate with respect to x1, which is equal to minus 10. See, I am writing it is minus 10. Similarly, y12, that means I am going to take the partial derivative of y1 with respect to x2. There is no x2 term here, so it will become 0. Similarly, y13, in y1 we are going to differentiate with the x3. So here x3, the derivative of x3 is equal to 1. So I am writing here it is 1. y21, that is partial derivative of y2 with respect to x1. Where is x1? There is no x1 term. So here it is 0. Now with respect to x2, it is minus 4. Then with respect to x3, which is equal to 2. Then y31, that means partial derivative of y3 with respect to x1. The derivative of x1 is equal to 1. With respect to x2, the derivative of 2x2 is equal to 2. The derivative with respect to x3, which is equal to minus 8. So we have a composite of a matrix which is generally known as it is higher order Hessian matrix, because we are considered more than 2 independent variable. We have 3 independent variable, that's why we have a 3 into 3 matrix or 3 by 3 matrix. So by using this matrix, we can now interpret whether the function is minimum or maximum. See, for that we have to take the principal minors. What are the principal minors? h1, h2 and h3. See, what is h1? I am writing here it is h1 is nothing but it is the first principal minor, which is minus 10. So y1, which is the minus 10, which is less than 0. Now we are going to consider h2. What is h2? It is 2 by 2 matrix. See, what is 2 by 2 elements here? Minus 10, 0, 0, minus 4. I am writing here it is h2, that is y1, y11, y12, y21, y22. So all these elements are here, that is minus 10, 0, 0, minus 4. So if you go for taking the determinant of h2, how we are going to find the determinant? The product of principal diagonal minus the product of off principal diagonal. So here in the principal diagonal, we have minus 10 into minus 4, which is equal to 40. Minus will become plus, so it will be 40. Minus 0 into 0, it will become 0. So we have only 40 value. So the determinant value of H2 is equal to greater than 0. Now, the third determinant, that is H3, that is we want to calculate the determinant value of this 3 by 3 matrix. So how to find the determinant value of a 3 by 3 matrix? I am not going to discuss in detail here. See, the first we are going to consider the first element, that is minus 10, then crossing the concerned row and concerned column. See, taking first element, that is minus 10, crossing concerned row and concerned column, then we have the 2 by 2 matrix. We have to take the determinant value here, minus 4 into minus 8, which is equal to 32, minus 2 into 2, which is equal to 4, then minus 0, second term 0. So 0, if you are going to consider the 0 elements, of course entire value will become 0. So I am going to take the third one plus third element plus 1 into crossing the concerned row and column, then 0 into 2, it will become 0, multiplied by minus 1 into minus 4, which is equal to minus into minus, which is equal to plus, so it will become 4. So if you go for taking the determinant value, you just want to simplify and calculate accordingly, so it will become minus 276. Minus 276, which is nothing but which is less than 0, that is H3 is equal to less than 0. So see here, what are these things? H1 is less than 0, H2 is greater than 0, H3 is less than 0. We have a different or alternative signs are there, so we can say that this given function is maximized. So in this way, we can find the higher order Hessian. So higher order Hessian we are mainly using when we have more than 2 independent variable. When we have only 2 independent variable, then we are simply using the plain Hessian matrix or Hessian determinant.